For this deep dive, we're turning to a great source, Bossil's Knowledge Bunker.
Oh, those guys are good. Super practical stuff.
Yeah, their whole theme is giving IT back, which I love.
It's about sharing knowledge, right? Not hoarding it.
Absolutely. It seems like every day there's a news story about some big data breach or some company getting hit with a massive fine for not handling customer data properly. It's like a constant barrage of reminders that keeping our data locked down in the cloud, especially with all the complexities, different laws and regulations, is, well, maybe the most important thing to get right these days.
Oh, absolutely. I mean, it's not just an IT issue anymore. It's a core business risk. And that's why we're going deep today into Azure storage security. Specifically, we're going to be pulling out the key insights from this guide called Azure Storage Security, Protecting Your Data in the Cloud by Query Dumpster. Really gives you a solid framework for thinking through how to approach this whole thing.
So when we talk about Azure storage security, we're going beyond like basic password protection, right? And this guide seems to delve into some pretty specific and, from what I've skimmed, crucial areas. What's the roadmap for this deep dive?
Yeah, we'll be looking at the concept of data sovereignty, like where your data lives geographically and why that even matters. Then we'll dive into access controls, who can get to your data and how. We'll talk about encryption, making sure your data is scrambled and unreadable if it falls into the wrong hands. And finally, we'll look at some of the unique security features you get with Azure SQL databases. It's kind of like peeling back the layers of an onion, right? Each layer adds another level of protection.
Sounds good. So by the end of this deep dive, the goal is that our listeners will be able to confidently secure their Azure storage without needing a PhD in cryptography.
Precisely. Slide 1, right off the bat, tells us what we're in for. It lays out the aim of this whole guide. It wants to explore, as it says, those essential concepts for Azure data protection. So let's jump right into it. Where your data lives in the cloud, it's more than just convenience. It's about legality and security.
Right. And that brings us to slide 2, data sovereignty. This might sound a bit, I don't know, academic to some people, but it's actually crucial when you're dealing with the cloud.
Oh, for sure. I mean, it basically boils down to this. Which country's laws and regulations govern your data based purely on where it's physically stored? This matters a lot when you think about privacy laws like GDPR in Europe or CCPA in California, and even the risk of foreign governments trying to access your data.
So it's not just about physical security of the servers, but also the legal jurisdiction your data falls under.
Yeah.
So how does Azure, with its global presence, tackle this whole data sovereignty puzzle?
Well, they've got this clever system of paired regions. Instead of one massive cloud, Azure is split into these independent regions around the world. And here's the kicker. Each region is paired with another one in the same geographical area. And these paired regions are designed to keep your data where it needs to be legally while also adding a ton of resilience.
Okay, so paired regions, they're geographically linked, essentially a primary and a secondary location for your data. But what's so great about this setup?
Well, let's break it down. First, you've got physical isolation. Azure tries to keep paired regions at least 300 miles apart, whenever possible, of course. It's like, imagine you have a main office building and then a backup site for disaster recovery. You wouldn't want them right next to each other because if one goes down due to, say, a natural disaster, the other one is probably toast too.
Yeah, it's like having backup generators, but they're both in the basement and it floods. What good are they? So distance matters. What else?
Then there's platform replication. This is where services like geo-redundant storage, GRS for short, come into play. Essentially, your data is automatically copied over to the paired region. Think of it like, you know how your computer backs up your important files to an external hard drive? Same idea, but it's happening constantly and seamlessly in the background.
Okay, so you're always backed up, always have a copy. But what about keeping the system up and running when Azure needs to do maintenance or updates?
Well, that's where sequential updates come in. Azure's smart about this. They don't update both regions in a pair at the same time. They do it one after the other. It's like if you had two servers running a critical application, you wouldn't take both of them offline simultaneously for maintenance, right? It's all about minimizing downtime and avoiding disruptions.
Makes sense. Keeps things running smoothly. Now, back to the legal side of things. The guide mentions data residency. How does this tie into the whole data sovereignty discussion we started with?
This is where it all comes together. Paired regions are always within the same broad geographic area like the European Union or the US. So if a company in Germany needs to keep its data in Germany, by choosing a German Azure region, they know it's paired with another one in Germany. That way, they stay compliant with data residency laws.
Okay, so location matters not just for performance, but also for legal reasons. Let's move on from digital borders to digital gatekeepers. Slide 3 is all about Azure Storage Access Controls.
Yeah, this is about making sure only the right people and applications have access to your data. And the fundamental rule here is this. Every request to access your Azure storage needs authorization. No exceptions.
Sounds strict.
Oh.
So what are the different ways Azure allows you to, control who gets in and who stays out?
Right, so there are a few methods here. First, you have shared key authentication. It uses your storage account access keys. But think of it like the master key to your house. If that key gets lost or stolen, anyone can get into every room.
So maybe not the best for everyday use unless you really trust everyone with your master key.
Exactly. That's why shared access signatures, or SAS, are often a better choice. These are like temporary access passes with very specific permissions. Imagine giving someone a key card that only opens one specific door in a building and only for a limited time.
Much more secure, right?
Absolutely. And then there's Azure AD integration, which uses identities managed in Azure Active Directory to control who can access your blob and queue services. Yeah, so instead of messing around with keys, you're granting access based on user accounts and their roles. Think of it like using employee badges to access different areas of an office building. Your badge determines which doors you can open.
Okay, so it's all about tying access to specific identities rather than anonymous keys. What about Azure AD Domain Services? I saw that in the guide.
Right, so that one's specifically for Azure files. It lets you use the same security model you're familiar with from on-premises file shares, using Active Directory to control who can access files and folders.
Makes sense. And then lastly, we have anonymous access. That sounds a bit counterintuitive in a security discussion.
It is. This is where you allow public read access to specific data. Use it sparingly. It's like putting a document on a public website. Anyone can see it. Make sure you really want the world to see it before you enable this.
Yeah, definitely something to consider very carefully. Now, the guide has this really strong recommendation regarding SAS.
Oh yeah, never ever share your storage account keys directly with external applications. If you need to give them access, use SAS. That way you control exactly what they can do and for how long.
Got it. So SAS is your go-to for controlled temporary access. Now, let's unpack those shared access signatures a bit further. Slide 4 dives into the different flavors of SAS and formally introduces us to Azure AD authentication.
All right, so with SAS, there are different levels of access you can grant. You've got service level SAS, which is like giving someone a key that only opens one specific room in a building. It limits access to just one Azure storage service, like blob storage or file storage.
Okay, very specific access. What's the next level up?
That would be account level SAS. Think of this like a master key card that opens several rooms, but not necessarily the entire building. It can grant access to multiple storage services, and it can also be used for some account level operations, but it requires more careful management because it's more powerful.
And then there's user delegation SAS, which, if I remember correctly, actually ties into Azure AD.
You got it. User delegation SAS is special because it's secured using your Azure AD credentials. It adds another layer of security because the access is ultimately linked to a verified user in Azure AD. It's only for blob storage, though.
Gotcha. It sounds like that's the most secure of the SAS options. Now, let's talk about Azure AD authentication itself. It seems to be a pretty big deal for overall security.
Oh, it's huge. Azure AD authentication provides a really robust way to manage access to lots of Azure resources, including storage. It uses something called role-based access control, or RBAC for short. It's all about assigning specific permissions, like can you read, write, delete to different users and groups.
RBAC, yeah, I've heard that term thrown around a lot.
Yeah.
How does it work in practice for Azure Storage?
So Azure has these built-in roles specifically for storage, things like Storage Blob Data Owner, Storage Blob Data Contributor, and Storage Blob Data Reader. They define what you can and can't do with your data, and keep in mind it takes a few minutes for those role assignments to fully propagate, so be patient.
So we have different types of SAS for more temporary or specific needs, and then we have Azure AD authentication with RBAC for more permanent and identity-based control. It seems Azure provides a pretty flexible system for managing who gets to do what. Now, let's talk about protecting the data itself. Slide 5 is all about storage service encryption and immutable storage.
Yeah, this is about making sure your data is protected even if someone manages to get past your access controls. So let's start with storage service encryption. Here's the key takeaway. It's enabled by default for all storage accounts, and you cannot turn it off. It's just built-in security, like, how your car automatically locks the doors when you drive.
Okay, so you get basic encryption out of the box.
Hmm.
What about if you have more specific requirements or need more control over how your data is encrypted?
Well, Azure gives you options. By default, they use what's called Microsoft Managed Keys. It means Microsoft handles the encryption keys, keeps them secure, rotates them, the whole 9 yards. You don't even have to think about it.
Sounds convenient, but what if you want more direct control over those keys?
Then you can choose Customer Managed Keys. This is where you manage the keys yourself, typically storing them in Azure Key Vault. Think of it like having your own safe in your office to store important documents, instead of relying on the building's general security.
So more control, more responsibility. I noticed the guide also mentioned an even more granular option, customer-provided keys. What's that about?
That's for really fine-grained control. You can actually provide a specific encryption key for individual blob operations, like uploading or downloading a file. Azure will use that key just for that operation and then discard it. It's like using a one-time code to open a safe deposit box.
Okay, so you have different levels of key management depending on how much control you need and how sensitive your data is. Now, what about immutable storage? It sounds like it's about making sure data can't be changed or deleted once it's stored.
Right, so with Azure Blob Storage, you can set data to be immutable, which basically means it can't be modified or deleted for a certain period of time. It's like writing something down in permanent ink, you can't erase it.
Sounds pretty secure. So how do you actually enforce this immutability?
There are two main ways. You can use time-based retention policies, which set a specific time period for how long data will be immutable. It's like setting a timer on a safe. You can't open it until the timer runs out. Or you can use legal hold, which is meant for preserving data for legal or investigative purposes. It stays locked down until someone explicitly removes the hold.
Makes sense. Does this work for all types of blob storage?
Yep, all of them. Whether it's hot, cool, or archive storage, you can use immutable storage policies to ensure your data is protected. And to keep track of everything, there's comprehensive audit logging. You can always see who accessed the data and when.
Okay, let's move on to file management in the cloud. Slide 6 talks about Azure Files authentication and secure transfer. It seems Azure is trying to make working with files in the cloud just as secure as doing it on a traditional network.
Absolutely. Azure Files aims to give you that same familiar file share experience, but with the added security benefits of the cloud. One key aspect is that it supports identity-based authentication over SMB, which is the standard protocol for network file shares. This means you can use your existing Active Directory or Azure AD domain services to control who can access your file shares in Azure.
So it's like having your network file shares, but in the cloud, with all the same granular security controls.
Yeah.
How does this authentication process actually work?
It's a multi-step process, but here's the gist. You set up your domain environment and establish a trust relationship with Azure. Then when someone tries to access a file share, Azure AD verifies their identity and issues a Kerberos token, which is like a digital ticket that proves they are who they say they are. And then that token is used to grant or deny access to the file share.
Okay, so it's like your traditional network login, but extended to the cloud. What's this secure transfer required setting that's mentioned on the slide?
That's an important one. Enabling this setting forces all communication with your storage account to happen over HTTPS, which is the secure version of HTTP. It's like putting a lock on your internet traffic, making sure no one can snoop on the data. And the good news is, this is turned on by default for new storage accounts.
Security by default, always a good thing. Let's turn our attention to databases. Slide 7 is all about Azure SQL database authentication and firewalls. Database security, that's got to be super important.
Oh, without a doubt. Databases often hold the most sensitive data, so keeping them locked down is paramount. Let's talk about authentication first. Azure offers two main methods. There's the traditional SQL Server authentication, which uses usernames and passwords stored in the database itself.
Right, that's the familiar way. But isn't it a bit, I don't know, old school from a security perspective?
It can be. Managing all those separate credentials for each database can be a headache, and it's not as secure as using a centralized identity management system. That's where Azure Active Directory authentication comes in.
So it's bringing databases under the umbrella of Azure AD. Much more secure. and probably easier to manage from an IT perspective.
Exactly. And Azure AD has all those great features like strong password policies and multi-factor authentication, which you don't get with SQL Server authentication.
So once someone is authenticated, how do you control which network traffic can actually reach your database server? That's where firewalls come in, right?
Yep. Azure SQL Database has a built-in firewall that blocks all access by default. It's like having a big keep out sign in front of your database. You need to explicitly allow specific IP addresses or ranges to get through.
So if I understand correctly, you can set firewall rules at either the server level or the database level.
That's right. Server-level rules apply to all databases on that server, while database-level rules are more specific to a single database.
And the guide suggests using database level rules whenever possible, right? More granular control.
Precisely. It's all about minimizing the potential damage if a firewall rule were to be compromised. You don't want one bad rule to give someone access to all your databases.
So we've covered who gets in and how network traffic is managed. Now let's peek inside the database itself. Slide 8 is all about database auditing and vulnerability assessment.
All right, so this is about keeping an eye on what's happening inside your database and proactively checking for weaknesses. First up, Azure SQL Database Auditing. This lets you track all sorts of activities like logins, queries, and data changes. Think of it like having security cameras and logs for your database.
So a detailed record of who did what and when. What about finding potential security holes before someone can exploit them?
That's where SQL Vulnerability Assessment comes in. It's an automated service that scans your database for known vulnerabilities and security misconfigurations. And here's the great part. It doesn't just point out the problems, it gives you actionable advice on how to fix them.
So it's like a security audit with a handy to-do list. Very helpful. The slide also mentioned advanced threat protection. That sounds pretty serious.
It is. This is where Azure uses fancy security analytics to detect unusual or potentially harmful activity in your database. Things like SQL injection attempts, weird login patterns, or brute force attacks. If it spots something fishy, it sends you an alert so you can investigate and respond quickly.
It's like having a guard dog that barks when it senses danger. I see there's also a mention of data discovery and classification and audit reporting. How do those fit into the overall picture?
So data discovery and classification is all about figuring out what kind of sensitive data you have in your database and labeling it properly. It's like taking inventory of your valuables so you know what needs extra protection. And audit reporting provides tools for analyzing those audit logs we talked about earlier so you can generate reports and gain insights into your database activity.
Okay, so a multi-layered approach to database security. Let's move on to slide 9, which dives even deeper into data protection within Azure SQL Database. We're talking about dynamic data masking, transparent data encryption, and always encrypted.
Right, so these are specific techniques for protecting sensitive data at different levels. Let's start with dynamic data masking, or DDM. It's like putting a black marker over certain parts of a document before handing it out. The original data is unchanged, but anyone who's not authorized to see it will only see the masked version.
So it's like redacting sensitive information without actually altering the underlying data. What about transparent data encryption?
TDE is all about encrypting your data while it's stored on disk, including backups. It's automatic and doesn't require any changes to your applications. Think of it like having your hard drive automatically encrypted, so even if someone steals it, they can't access your data.
And lastly, we have always encrypted. This one sounds intense.
It is. Always Encrypted is designed to protect the most sensitive data, even from database administrators. The encryption happens within your application before the data even reaches the database. The database server itself never sees the decryption keys, so even someone with full admin access can't peek at the data.
Wow, that's a serious level of protection. It's like sending your data in a locked box that only your application has the key to open. The guide mentions that this is especially useful when you're dealing with third-party database providers.
Absolutely. It gives you a lot of peace of mind knowing that even if you don't fully control the database environment, your most sensitive data is still protected.
So to wrap up this deep dive, it's clear that Azure storage security is a multifaceted beast. We've covered everything from data sovereignty to access controls to encryption to database-specific security features.
Yeah, it's a lot to take in, but the key takeaway is that securing your data in Azure requires a holistic approach. You need to think about where your data lives, who has access to it, how it's protected at rest and in transit, and what additional security measures you need for sensitive data within databases.
Well, I'd say this deep dive has given us a lot to think about. So for our listeners, here's a question to ponder. As cyber threats become more sophisticated and data regulations get even more complex, how will you leverage the principles of data sovereignty, access control, encryption, and database security to build a truly resilient and secure cloud environment?
And remember, it's not just about implementing every single feature. It's about understanding the tools and choosing the right ones for your specific needs.
Exactly. Until next time, keep those clouds secure.